So I'll be talking about GraphQL and Postgres. Postgres is a database, if you don't know it. And I'll basically talk about how to make it easy for you to persist data that you have in React to the server using as much or as little code as possible. So first, let's talk about state. And when I mean state, obviously, I don't mean the United States. I actually mean our typical component state and other places of state. So when you start a new React project, you have a lot of state, right? Like you keep adding things, and you have unless you do Redux from the start, you have a lot of different places of state. Then at some point, you introduce a store. And then at some point, you introduce the server, right? And so to me, that's kind of the focus of the talk is going to be what's the magic thing that happens between kind of the store and the server. And I also want to say, serverless, which is a really nice buzzword nowadays, is not stateless, right? So like if you have serverless and use Amazon Lambda, for example, you are always storing state in a database. You have like Dynamo or like any other database on the server. And so we still have to think about these things, right? Like it's not like magically we can send stuff into the cloud and it comes back. So let's kind of dive into what is this magic server. And so typically you have the service you directly talk to. That being your Node.js server, your Rails server, your Go server. And then you have the database. And I think what's interesting to me is we talk a lot about these servers, but we don't talk a lot about the database, right? And you have a lot of people accessing your servers and your database. People being cats in this case. And so I think what's important to recognize is that we ultimately have our state in the database, right? So like, it actually doesn't matter as much what's in between. What matters is, what's the source of truth? Where do we actually get our data from? And so I think this is why we should be talking more about databases and not just about the next best server technology or serverless. And I'll quickly talk about picking a database, mostly because I know people have preferences, and I know there was a Rethink DB talk yesterday. And I maybe start with that. I don't think that there's one good answer, right? I think you see companies saying Postgres is great, then you see Uber migrating from Postgres to MySQL, then you see CockroachDB, you see MongoDB. Like there's so many things, and so I think there's not one answer. But I'll try to give you an answer that kind of makes sense for me. And so I personally always prefer Postgres. And the reason I prefer Postgres is, first of all, it's fast and reliable. And this might seem obvious, but for example, DynamoDB is actually not that fast. Like the latency can be 30 milliseconds, 50 milliseconds. Like it's actually quite slow. And if other like Cassandra also has its own issues. Also, it's reliable. It's been around for some time, so you're not going to be broken by like the next release. The other thing is you can deploy it anywhere. So I think that's for me. So my background is I used to be a backend, or I used to be a server person, then I was a backend engineer, then I was a front-end engineer, and now I'm the front-end engineer in a team of database engineers. So I care a lot about these things, more than you probably do. But one thing I think which is important for a whole team is that you can deploy your database anywhere. So you don't have to just use Amazon or just use Google. You can actually go to, you can make it independent, basically. And the third part is, I think it's really important to recognize that Postgres is a 100% open source database, and this is mostly because there's stories like database companies selling to Apple and then they close the source, or stories of like database companies mostly having their own agenda. And so I think important with Postgres is it's a community project. It's like the Linux kernel for what's good and what's bad. Like there's a lot of discussions, but I think it's good because it's a community project, and it's not just one company, it's multiple companies, so it's not going to go away. And there's lots of other things. So you can, if you search for Postgres online, we could talk hours about this, but I'm not going to. Instead, we're actually going to focus on an actual app that we're going to build. And so initially, I wanted to talk about dashboards and stuff, mostly because I work with dashboards every day. But then I realized dashboards are actually kind of boring. It's a dashboard, like D3 is interesting, but the data in a dashboard is not that interesting. So we'll not talk about dashboards. We'll actually talk about React Music. How many of you have seen that? Quick show of hands if I can. OK, so like maybe 1/4. So React Music is really fun. It got released this Monday, so you know how fresh these slides are. But basically, React Music is a way to get a sequencer and a digital, basically get your own digital music production going in React in the browser. And it only works in Chrome and Firefox right now, so you can't really do it in mobile. But it's a really fun project. And you should check it out. It's not my project. It's Ken Wheeler's project. But we'll use that as a base. It looks kind of like this, right? So like you basically have React components, and then you have like sampler and a sequencer, and you have like synthesizers and so on. And he's like, today he just released a new version with like lots of new features, so he's actively working on that. But we'll basically take that, and our goal is that we want to build a backend for that React music, right? So like the idea is right now you have a client-side React component, and instead of having just the client-side component define what music is playing, we'll get it from the server, and we get it from a Postgres database. And we'll call it BeatQL, because, might as well add another QL. And you can check out the code right now if you want to follow along. Maybe for people on live stream, it's a bit easier. Name is LFITTL, the first letter from first name and my last name. I'll also tweet it out later. So we're going to build a working thing. First of all, maybe choosing a backend library, right? Like, so this little server that sits in between a database and your client code, what are we going to use? And so the easiest thing that I've found so far is GraphQL.js and PGPromise, PGPromise being the Postgres library, and GraphQL.js being the reference implementation. I've also played with GraphQL Ruby a lot, but to be honest, it's just easier if you stay in JavaScript all the way. So that's that. There's also a great project called PostgreSQL. I actually, for the first time, I met the person doing this project last week for coffee. He's a great guy. You should check it out if you don't want to customize it as much. It's really focused on, run a server and not write any Node.js server-side code. But it's a good experience. And of course, I could also have written a new library, right? So this is, and I kind of have this as this thing myself that I start new projects way too often. But I think it's important to recognize, hey, maybe we can reuse what exists. And so that's why we're going to focus on using GraphQL.js, using PGPromise, and also using data loader, which is really helpful Facebook project. So maybe just to start with this, so we want to figure out the schema, what data are we storing. And so the basic primitives in React Music are songs, sequencers, and instruments. So a song is basically just a thing that has a tempo and contains multiple sequencers. A sequencer has a beat, a number of beats, and an instrument is something like a synthesizer or a sampler that belongs in a sequencer. And you can kind of see this when we go back here. This is basically these components. And so we want to store these components in the database. So we're going to look at SQL. And I know this is one of the things that people don't like Postgres or MySQL, because they have to think of it as SQL and it can't just send a JSON blob. But I actually think it's, once you understand that it's a good thing, it's actually a good thing. Anyhow, so our schema is going to look like this. And for those of you who don't work with these things, so basically all we're doing here is a song has an ID. It's going to be UID, so it's going to be a randomly generated string. It has a tempo, which is an integer like 190. And it has 2 timestamps, like when it's created and when it's updated. And we do a similar thing for sequencers. Sequencers have resolution and number of bars. And then we have instruments which have which belong to sequencer and have a certain instrument type, and also contain data. And so this is maybe a good showcase of why PostgreSQL actually works well with this, because we don't have to tell it, hey, this is the full schema. We can actually say we want to store an arbitrary blob of JSON data. And Postgres has a type called JSONB, which is for binary JSON. So basically, it's you can do indexes on it. It's actually quite efficient. It's kind of like MongoDB's BSON. So we're going to use that for storing the gist of which sample file are we playing, how many steps does it have. And then we're also going to create an index. Again, something I'm not going to talk about much in this talk, but do care about that when you use a database that it has indexes. And this applies universally. Almost every database needs an index, so you can tell it what you want to search for. So in this case, we care about searching for sequencers by song ID, and then also instruments by sequencer ID. Cool. So GraphQL. I hope most of you are somewhat familiar. So I'm not going to jump too much into GraphQL itself. Maybe just looking over the schema. So we have, again, a song, looks pretty much the same. Also, we're going to use relay, mostly because it's a good best practice. We're going to have a sequencer. We're going to have an instrument. And these are all connected using the relay primitives, basically. And then we'll load a sample data. And so this is kind of where the true kind of power of this approach comes, because right now you'd have to write a React component, and this can actually be data in the database. It might look like it's harder to read than a React component, but the benefit is I could actually share this with you. I can, there couldn't be a database in between us. I upload the data, you download the data. And this is essentially the example that Ken Wheeler has in React Music in a demo. And we're also going to, the code is based on Relay Starter Kit, because that's easy. So again, looking at this, we have, a pretty simple layout. We have a client, we have a data folder, and we have the server. Then there's public and scripts. It doesn't matter as much. And we'll focus on client and the data. So data is kind of the place where we have the GraphQL schema, and also the place where we load the information from the database. So here's kind of, and this is a try at me making this easier. Historically, what you've done is you've done a lot of complicated functions. I basically tried to use ES6 classes to tell the thing what the database like columns are called. So like in the database, you have a primary key, you have a table name, you have a field to call it, like you have a column name. So basically, instead of saying, here's a complicated function, let's try putting it in an ES6 class. And this is not perfect. It's more like the idea. And so we also have a constructor that would take the information from the database and transform it to this like model, basically. We do the same for a sequencer. We do the same for an instrument. And then here, this is kind of showing how easy it is. So we're creating like this PG promise object, which is basically the database connection. You just pass it like a host name and a port. And like the README for a project, there's the quick startup Docker to have a Postgres database. Not much work. And then we're going to use data loader, and I'll talk about that in a second. We'll use data loader to access that database. And then these exports are basically the functions that our schema needs. Like when we want to, in the GraphQL schema, actually load data, we'll call one of these functions. So get song is going to be the first one, and then we'll call like get sequencer for song and get instruments for sequencer. And always passing in like the object that we want the information for. And so just for example, this is kind of the example of a song in the GraphQL schema. And here you can see, here's actually a little detail which is, might not be as familiar to people. You can return promises from resolve functions. So instead of basically having the resolve function do everything and then return the result, you can actually return a promise, which turns out to be really, really good because you can parallelize your processing on the server. So instead of doing it sequentially, like just sending one query after another query, you can actually, if you have like a node and then two different like subtypes, you can actually run queries in parallel using promises. And there's connection from promised arrays basically coming from the GraphQL helpers library. And the same thing is for a sequencer. There's not much to that because it's mostly calling the functions from the other place. Let's see. Cool. And then I think that's maybe just the last piece of the schema that's important is you have connections between those nodes, as you have in a Relay app. So again, this is standard stuff. And then you basically, in this case, we always look up one song, and like this really long string is the UUID of that song. So you could imagine this being like in the URL, and you look it up based on the URL or like some other lookup mechanism. For simplicity's sake, right now, we just query for a song. We always get this one song. All right. So going more into what actually matters. So because up until this point, you could have probably done this already. Like there's nothing magic to it. And I think this is actually, if you just look through the like apart from the ES6 classes maybe. But like anything else is just standard GraphQL and Postgres. I think what's important is, and this is something that a lot of people talk about, but there's not many good solutions, is you don't want to always ask for all the data. So a lot of people, when they use Postgres or a database with GraphQL, they always say, select star, which means select everything. So like give me like the created at, give me the updated at, give me like all the information you have. And often you don't need that. And maybe more importantly, it's actually an anti-pattern in Postgres. So you shouldn't always query all data. The best example is if you have a column which has an index and you're only asking for that column, it's much, much faster. Like, because it can only get the data from the index. It doesn't need to actually go to the table on disk. So, you really shouldn't do this. And this is kind of the main conversation I have with people, like, how does this work? And the gist of it is you want to like pick the fields from kind of like the GraphQL schema, or the GraphQL query actually in this case, and you want to transform these fields to be the column names in the database. So this means, camel case versus underscore is the typical case. But basically, you want to transform this query so it actually runs this query in a database. And this is where you probably want to look at the source instead of me talking through it. But basically, there were a couple of people in a GraphQL.js issue talking about what's the best approach to do this. Because the problem is if you are in this resolve function, you actually don't have enough context. So you don't know the fields that are being queried, especially if you use fragments. And then it gets really complicated. So here you see like the first part is actually the easy part. And then there's like, to this like get field list function, there's like another half, which basically deals with how do you get the field names from our fragment list. Anyhow, so the good thing here is you don't need to do this like specialized for every type. You can actually just import that function and it works. And I slightly modified the function that's in that issue, so credit to the person who wrote that. And I fixed up the relay support. But you probably want something like this if you work with a database in GraphQL. And we can, always have to talk about more details on that afterwards. The other big thing is avoiding n+1 queries. So and maybe explain what an n+1 query is. So if you say, give me a song, and then you also want to have a second or a third song. And then for each of these songs, you want to have a list of sequencers. And then for each of these sequencers, you have a list of instruments. And so the tricky part is you don't want to make a query for every one of these questions. So you don't want to say, give me the sequencer for this song, and now give me the sequencers for this song. Mostly because you have a round-trip time. So you always go to the database and back again, and it just costs you time. And that's kind of called the n+1 query problem. And you want to avoid the n+1 queries. The way to do this is data loader. Data loader is, again, a Facebook project. It's mostly a helpful JavaScript library. It actually doesn't do that much. It's just a pattern. And I think, and this is an oversimplification of the data loader pattern intentionally. So we have a function, and this is again a helper function, which creates a data loader. In this case, it's called load many. And load many takes one of these ES6 class definitions. It takes the database connection, and it gives you a data loader object. And so this data loader object, you can call .load on. And every time you call .load, it actually doesn't load the data. It basically just queues it up to be loaded, returns a promise. And then at the end, you basically, when you get the result of the promise, you just run one query for like all of these .load statements. So that's kind of the data loader pattern, made a little bit easier using like these helper functions. And you can see here, like this is basically, like it takes this information, it instantiates a new data loader, and then it just composes a SQL query. Let me just look where we are in time. Okay, so I think we're good on time. So that's basically, the gist of it. And I think the important thing here is, so you could have an ORM in the backend. You could have used like one of the more complex node ORMs. But I think often you just really need something that creates an SQL statement. And then, maybe going into the client. So the client here is really simple. So the client just runs a relay query. It's actually kind of an ugly relay query because I'm just getting all the data for the song and I don't care about fragments. So you could make this much nicer. The gist of it is here, we have like the typical relay, edges and then the node itself. We care about the tempo of the song. We care about the resolution, the bars for the sequencer. And then we care about the instrument type and like the actual data for the instrument. And perfect. So this is kind of the last piece of the code. So here what you're doing is you're importing the React Music components. They're actually fairly easy to use. And then you're just passing in the relay props to that React Music component. All right, so let's see if we can do a demo of that. And if we have sound, now is the time that we'll need it. Let's see. So, all right, cool. So maybe, to have the full picture. So essentially what I have is just a checkout of that repo. And again, that's on GitHub. And we just do npm start here. And then the thing, and this is kind of from Relay Starter Kit, the thing it always does first is it updates the schema. So it loads the GraphQL schema and generates a schema definition that both the client and the server need, which is kind of it's actually odd. Like the first time I saw this, it was kind of like, oh, this is weird. Like, why is my schema on the client as well? Like, why is it not just on the server? So that's kind of a gotcha if you haven't used Relay before. And then let's see. Okay, so this is rendering. It's not showing anything, and the reason is because if we look at our database, is we have these three tables that we talked about previously. We have our songs table, we have our sequencers table, and we have our instruments table. And so basically, just looking at the data here, so songs has one song in there right now. I previously inserted that. But we don't have any instruments, and we also don't have any sequencers. Exactly. So this is why right now it's not playing anything. So let's see if this works. We're going to add a really simple beat first. And then we'll have to reload. This actually, that's perfect. Cool. So right now you have to always reload because it always has to go to the server again and reset the sequencer also. At a future point, what I actually want to really have is, have the server, the database, push down if there's new information. And with Postgres, you can do that. So you have a thing called listen notify, which allows you to push as kind of like, like a WebSocket, like saying, hey, there's new data, you should update. So, at a future version of this talk, I'll incorporate that. And now basically we can just, whoops, don't open Slack. Sorry, wrong. All right, adding another instrument. And again, this is all React music, right? So like the magic that moves those, the visualization and the actual playing, this is not my thing. That's all React music. But we mostly care here about how does the data get in. And then we can just, keep adding data, basically. And you can kind of see the visualization, also takes that into account. And let's see. And so now you have like a nice, thing going there. Let's see. Yeah. That's kind of like the last pattern we added. And it just keeps looping, basically. But so the nice thing here is, if we wanted to, we could just, add another sequencer, add another instrument. Actually, so last night, as I was finishing up, this code and the slides, Ken Wheeler actually released a new version of React Music, and so I was like, oh damn, like I already have everything prepared, and now you're doing this new thing. So you can now actually do like polysynths and like filters, and there's a lot of functionality that I actually haven't added here yet. Mostly this would involve, changing the database, the data model. Changing the GraphQL schema. Let me just stop it again. But basically, you should check out React Music. And so that's kind of, and I'm actually, I'm short, like I already went too fast. So I'll tell you a little bit more about things, just if we have another 5 minutes or so. So let me tell you how I see this working, right? So we're not just, right now we're just loading data, we're just, showing it in the client. The next step from that would be, let's add mutations, right? So let's actually add a way to influence the sequencer. So if you have a step sequencer, maybe you have a button, right? And you can toggle a button, and then that both updates the browser, but then it also goes to the server. And so I think that's the obvious next piece, because then you actually have a digital audio production system in a really simple way. And then the other piece that I kind of mentioned is, what if we could push data down to the client as it changes, right? So this could be, and in my imagining what this talk could have been if I had endless amounts of time, you could have your mobile phone, and you could change something on your mobile phone, and it would update on the screen. And technically, that's actually possible, right? So technically, all you need to do for that is you need to use PostgreSQL's listen notify, which when data comes into a table, it basically helps you call a function, and that function can do things. Specifically, it can tell, for example, a JavaScript server, hey, there's new data coming in, and that JavaScript server then could do a WebSocket, could do a add live query, could do a subscription. And I think one of the issues I actually ran into when looking at that is like there's no best practice yet, right? It's like Facebook is kind of pushing towards subscriptions. I kind of found live queries the most interesting, so I was like, I want to have, like, just update the thing for me. And you can still use WebSockets. I think that's really the interesting piece is like, how can we enable like a reactive backend, right? Like how can we have our database collaborate with us in both ways? So we're not just sending data in, we're actually getting information. Let's see. What else could I talk about? Because I have 5 more minutes, I think. Let's see. So let's do one thing. So let's just go into, what are we actually doing here in terms of how are we actually getting this information. I think this could be interesting just to explain it better. So again, talking about this actually, right? So I think, and actually let's do the following. Let's look at this. And let's make this smaller and this bigger. Okay, cool. So I think it's important to me to explain that this is actually easy, right? Because I think a lot of people are like, oh, database, that's complicated. I don't want to touch it. I'm a front-end person. And that's nothing against front-end people. I'm actually a front-end person myself. Like, it's more, I think it's important to say, hey, this is actually not that complicated. And so I think, going over this again, so we have ES6 classes. So we have our ES6 classes. And then really the important thing here is, so we use data loader, like we pass in a name, the name of the class, right? And then we have our little helper function. And this little helper function actually takes this model and, takes the static properties of that model. And so I think, like historically, the whole Node ORM space hasn't done that. Like it's been a little bit painful to use in my experience. And so I think it's maybe important, how can we, and this is a challenge for us as a community, is like how can we make this easy so you don't have to look at this. You can actually, just look at an ES6 class as if you're looking at a React component. And how can we make that so simple that you don't have to bother about all the database details. And then another detail here is maybe to, a thought or an idea that's important here is this, like a query comes in, you do a certain mapping to the data that needs to be fetched, and then you get the data and you do a mapping the other way again, right? So you have like, in here it's just column names, but I think like GraphQL JS really does the most basic version, and I think Apollo, for example, does it a bit better. But I think we should focus, in terms of tooling, we should focus on how can we have this like two-way data binding, so it's like, like transforming the input data and getting the output data again. But yeah, I think that's mostly it. Are we ready backstage? Cool, okay, perfect. Well then, let me just show the last slide. Thank you. You'll find the project online or me on Twitter. Thank you.